Now we're going to talk about the arm ergometry equation. We have a case study, and Dan is our case study. He's a 61-year-old man. He weighs 127 pounds, and he's a coronary artery bypass patient. During his phase 2 rehab, he's introduced to the use of a Monarch arm ergometer. He's asked to select a comfortable resistance while cranking at 50 revolutions per minute, keeping his heart rate within a prescribed range. After warming up, he uses a resistance of 1 kilogram. What's his corresponding VO2 and what are his corresponding MET levels? Step 1. Convert any raw data. So we want to convert pounds into kilograms. We know he weighs 127 pounds. We're going to divide that by 2.2, and that's going to give us 57.7 kilograms. Then we need to figure out his work rate. So let me go ahead and write all this up. This is the same work rate as we saw for the cycling. There's one small difference. Meters per revolution. With the cycling, it was 6. With the arm ergometry, it's going to be 2.4. And again, that's always a given. You'll always use 2.4 for this part of the equation. Revolutions per minute, he was going at 50 revolutions per minute, and he chose 1 kilogram. So when we do that math, we're going to get 120 kilograms per meters per minute. And this is going to be what we're going to plug into the equation. So next we're going to move on to the equation. Let me get a new screen here. Step 2. Solve using basic algebra. Now, as you can see, there are two equations for both the cycling, the leg cycling, and the arm cycling. One uses watts, one uses work rate. If you were given watts, you would just plug it into the watts equation, but here we've been given work rate. So we have VO2 is going to equal 3 times the work rate divided by body weight, and then add in 3.5 at the end. So we're just going to plug in. 120 was the work rate. We're going to divide that by his weight in kilograms and add 3.5 in. Again, do all of this first. Do all of this first. Once you've gotten this number, then add your 3.5 in. And that's going to give us 9.7 milliliters per kilogram per minute. So that was step 2. One more new screen. Step 3 is going to be to convert. So for step 3, VO2 is 9.7 milliliters per kilogram per minute. In order to get METs, all we need to do is divide that by 3.5, which is going to give us 2.8 METs.